My dear students, in continuation of our Fourier series on the full range and arbitrary range Fourier series, let me consider the half range Fourier series. The explanation about this one is, in an interval of length 2L, we have seen that in an interval of length 2L, we have seen that in general, a periodic function of x will have Fourier expansion containing cosine terms and sine terms. It is already known by you because you might have seen so many examples of this type. Many times it becomes necessary to have the expression containing only cosine terms or only sine terms. Suppose this question happens, what shall we do? This is the condition of the half range Fourier series. Next, to obtain this, the function must be defined in the interval of the form 0 to L. Refer this one, 0 to L, which is to be regarded as half the interval. Why it is half the interval? Because we have seen 0 to 2L. Divided by 2 will be what? 0 to L, which is regarded as half the interval. We then extend the definition of other half in such a manner that the function becomes even or odd. How it is, we shall see now. This will result in cosine series only or sine series only. Suppose if we need either sine or cosine series separately, what shall we do? In that case, we need to go with half range Fourier series. Okay. Next, case 1 for the cosine series. And for the cosine series, f of x will be phi of x in 0 to L, and phi of minus x in minus L to 0. We make f of x is even. When you put x equal to minus x, if there is no change, it will be called even function, as you might already known in the first class of the Fourier series. The same definition I am going to use. If there is a minus, if there is a x is replaced by minus x, if it will become minus of the given function, I mean minus of phi of minus x, then f of x is odd. We have already seen that in the case 1, bn is equal to 0, because when the given series is even series, we are putting bn is equal to 0. Refer even and odd function. I am using that condition here. And in the case a naught equal to 0, n is equal to 0 when f of x is odd. That is, only we need to calculate bn in case of odd nature. Again, we shall use even and odd function. We have in the case 1 f of x equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x upon L, where a naught is equal to 2 upon L between 0 to L f of x dx, and n equal to 2 upon L between 0 to L f of x cos n pi x upon L dx. In case of cosine series, we need to calculate a naught and n in this manner, putting bn is equal to 0. And in the case of the case 2 means what? Odd function. F of x equal to summation 1 to infinity bn sin n pi x upon L, where bn is equal to 2 upon L between 0 to L f of x into sin n pi x upon L dx, because a naught and n equal to 0 in case of odd function. The series 1, this equation, which contains only cosine terms with constant term, which contains only cosine terms, this is called the cosine half range series. Fourier cosine half range Fourier series for f of x in 0 to L, and the series 2, which contains only sine terms, is called sine half range Fourier series of f of x. There is no such a huge change. A little bit change has been happened. Only the interval is between 0 to L instead of 0 to 2L. Otherwise, rest all the conditions are same. Refer this table. Similar consideration holds good for 0 to pi, as it is a particular case when L equal to pi. Suppose if L is replaced by pi, the first and second conditions are between 0 to L. Third and fourth conditions are between 0 to pi. Refer this condition in a very close manner. This will help us to go for some of the examples in the next class. Okay, my dear students, if you come up with any difficulty, please free to call me for any of your doubt to clear, because Fourier series requires some good calculus, and without pen and paper you cannot do anything. Do not go for that also. And again, one more thing, do not read the mathematics. Take the pen and paper, go for derivation, get the result accurately and speedily also. Okay, this is the requirement of the Fourier series. Okay, thank you.